Hello friends, welcome to EC Academy.
In this lecture, let us understand the operation of Class B power amplifier. Figure shows a Class B power amplifier. In Class B power amplifier, a transistor conducts only for 180 degree. To avoid the distortion, we use two transistors that will conduct for 180 plus 180, 360 degrees. So we can get a complete waveform at the output. So two transistors will be connected as shown in this figure. So one transistor conducts for positive half of the cycle and another transistor will conduct for negative half of the cycle. Hence, a transistor will push the signal towards positive half and another transistor will pull the signal towards negative half. That's why this circuit is also known as push-pull circuit. During positive half of input cycle, the secondary of the transformer T1 has the voltage V1. Hence, the transistor Q1 will be conducting and Q2 will be off. So as you can see, during positive half, we have polarity positive and negative, positive and negative. So positive connected to base of Q1 and this negative will be connected to base of Q2. That's why Q2 will be off and Q1 will be on. Since a transistor Q1 is on, the collector current flows through the transistor and the current will flow through the upper half of the output primary winding. This will produce the amplified and inverted voltage. During negative half of the input cycle, the polarities of these two voltages will change to negative and positive. So negative and positive. So due to these polarities, transistor Q1 will be off and transistor Q2 will be on. So since transistor Q2 is on, the collector current flows through the lower half of the output primary winding and this will produce the amplified and inverted output waveform. Since each transistor amplifies one half of the input cycle, the loudspeaker receives the complete cycle of the amplified signal. So this is the working of Class B power amplifier. The advantage of Class B power amplifier is that the efficiency is 78.5%. Since the efficiency is high, Class B power amplifier is commonly used in comparison with other power amplifier. Disadvantage: the audio amplifiers are bulky and they are very expensive. Now let us understand crossover distortion. To understand the crossover distortion, let us consider an AC equivalent circuit of Class B power amplifier. Since it is an AC equivalent circuit, we don't have DC power supply. When the small input signal is applied to this AC equivalent circuit, since there is no DC biasing for these two transistors, during positive half of input cycle, the transistor Q1 will be on, but it will not turn on until the input signal reaches zero point 0.7 volt. Once the input signal reaches zero point 0.7 volts and above, the transistor will turn on and that part of voltage will be available at the output, which will be inverted. During negative half of the input cycle, the transistor Q2 should turn on, but it will not turn on until the negative half of the cycle reaches above zero point 0.7. So Q2 will turn on only for negative half of the cycle above zero point 0.7 and it will turn off for the input signal less than zero point 0.7. That's why at the output you will be getting the signal only for zero point 0.7 and above. The transistor Q1 will turn on for positive half of the cycle and transistor Q2 will turn on for negative half of the cycle. But there will be a time for turning on and off of these two transistors, for that time the signal will be clipped off. The region where the signal is clipped off is known as crossover distortion. So due to this we will get output signal that will be clipped off, and this is a distortion that is caused at the output. Since the Q point of class B power amplifier should be on cutoff region, to avoid the crossover distortion, the Q point will be slightly above cutoff region as shown in this figure. So this will avoid the crossover distortion in the output. This is about the working of class B power amplifier. I hope you have understood the topic. Thank you.